question 65 gives us 2 points, and it asks us to find the equation of line passing through those points. And then it also asks us to check if another point is on that same line. Our textbook has given us some good skills for dealing with some things that I've never considered, and I've been doing these things for a long time. One of the things they talked about was just considering the general form of the equation of line y equals m times x plus b. That would be a line. And using 2 different points, like I'll call this point 1 and point 2, to write a system of equations in which you would only know, or you would know the x and y for both values, right? Because we have here, this is a y and this is an x. And there's a y and there's an x. So we would know the x and y's, but we wouldn't know the slope and we wouldn't know the y-intercept. So the values that we would get, m and b, would be the slope and y-intercept, and then we could use those to write the equation of the line. And that's certainly a great technique, and it's worked well for us. I'm going to go a little bit more back into definitions, what slope means, and I'm going to use that. It's a slightly different approach. So my goal is going to be, first of all, to find the slope of this line. And let me also say that you could solve this problem graphically. I would say that it would probably be difficult to find the equation of this particular line, but you could definitely get a large piece of graph paper and try and plot the points and accurately try to find both the slope and the y-intercept. But with numbers this big, I think probably we're better off if we're just using a non-Cartesian solution. So slope, if you'll recall, is the change in 2 values, right? The slope of any particular line is how fast its y values are changing, right? A change in its y values divided by a change in its particular x values. Change in y's are of course are the values that measure going up or down, and the x values measure going either to the right or to the left. So we're looking at this ratio of change in y over change in x, and that's what slope is. And because change in y is, at any point is the difference in 2 y values, right? I could look at a y value minus the other y value that I'm getting. So that's the change, how much y has changed going from the original point. Actually, I'm looking at the second one, y2 minus y1. I'm taking where I end up and subtracting where I began. And I'll do the same thing, change in x sub 2 minus x sub 1. Then for this particular problem, you can see I've labeled my 2 points. I've got point 1 and point 2. And I'm just going to use those designations to plug in the values of x and y to find the slope. So for the change in y's, I can see y's end up at the number 25, but they began at the number 7. So you see I've taken 25 minus 7. Then for my denominator, and I just got that, that's right. For my denominator, my x's end up at the number 30, but they began way back at negative 24. So again, the difference between where they end up and where they began, 30 minus a negative 24, that's a pretty significant change. So if we look at our numerator, 25 minus 7, I believe is a positive 18. And 30 minus negative 24 is a change of 54 units. Now if I grab my calculator and take a look at that, I'm going to take, I think it goes in evenly, 54 divided by 18. Yeah, it does. I get that that's equivalent to 1/3. So my slope for this particular problem, right, my slope, which is represented by the variable m, is equal to 1/3. That means for every 1 unit I go up, I move 3 units to the right. And I can visualize that and plot that. Now that I know the slope, I'm going to use that information to find the y-intercept. So I'm going to go back to this, y equals m times x plus b. And I'm going to plug a few different values in here. I'm going to choose to use the second point. I could use the first one just as well. But I'm going to use the x and y from the second point with the slope that I've just found. Right? The slope was 1/3. I'm going to use these values in order to figure out what b is. So you can see y in that first point was the number 25, and that equals the slope, 1/3, times an x value of 30 and then plus b. It's a beautiful equation. The only variable that's there is b. 1/3 of 30 is certainly the number 10. So I have that 25 equals 10 plus b. Therefore, if I subtract 10 from both sides, you can see I'll just write this down this way. B must be the number 15. So I know now both my slope and I know my b value, my y-intercept is the number, positive 15. So with those two pieces of information, I can write the equation of my line, right? My line is y equals 1/3 times x plus the number 15. So this is the equation of the line that goes through the 2 points I was given. The question I'm asked next is the point 5133 also on this line? And remember what it means to be on a line, right? It means that you're an xy ordered pair that satisfies or makes the equation true. So I'm just going to quickly test the truth here. I've clearly got a y value. The y value is the number 33. So I'm going to say, is 33 the same as 1/3 times my x value of 51 and then plus 15. So I think 51 isn't 51 prime? Maybe not. 51 divided by 3, oh no, it's not. 51 divided by 3 is the number 17. So 1/3 of 51 is 17, and then 17 plus the number 15 is 32. So what I've got here is on one side of this equation, I've got the number 33. Over here, I get that this is a 17 plus 15, which is the number 32. Well, as it turns out, these are different numbers. So when I plugged in the x and y from this other point, right, this point that they asked me to test, right here, x was 51 and y was 33. When I plugged those in, I got on one side the number 33, and on the other side I got the number 32. And although they're very close to each other, they would have to be exactly the same in order for me to say that 51 was equal, 5133 was on the line. So my answer here would be no, this point is not on the line. And the reason why it's not on the line is because it doesn't make the equation true. And by that I mean 33 is not 32. Oops. That's it.